So in this lecture, we will learn about the torsional vibration. So in this lecture, we are going to learn about torsional vibrations. So we will learn about the condition of the we will learn about the condition of shaft carrying a single rotor. Shaft carrying a single rotor. A single rotor. So the the schematic diagram for this condition will look like uh, this thing. So this is the rotor, and so this is the rotor, and from base of the rotor to this attachment the distance is L, and we are going to rotate this rotor with some angle theta. So when we rotate the this angle with some angle theta, then we are going to get counter force, that is I double theta, and also restoring torque here. So in this condition, we are going to assume that shaft is massless. This shaft is massless. Here G is equal to modulus of rigidity of shaft material J is the polar moment of inertia of the shaft. L is the length of the shaft. L is the length of the shaft. I is the mass moment of inertia of the given rotor, and Q, which is the ratio of G into J by L, is the torsional stiffness of the shaft. Torsional stiffness of shaft. So by equation of motion, by equation of motion, inertial torque plus restoring torque is equal to 0. That is I theta double dot plus Q theta is equal to 0. Now taking the item common, and let me take the item common, then we are going to get theta double dash plus Q by I theta is equal to 0. After further simplifying, we are going to get theta double dot plus q by I theta, that is double dot, equal to 0. And let me erase this thing. Now theta double dash is equal to omega n square theta is equal to 0. So omega n, that is the natural frequency, is equal to under root q by I, or we can write omega n is equal to under root gj by li. So if we are going to consider the mass of the shaft, so for this is a reason of our interest. Now if we are going to consider the mass of the shaft, so if we are going to consider the mass of the shaft, if mass of the shaft is considered, then the natural frequency is given by the formula omega n is equal to under root of q by moment of inertia of rotor plus moment of inertia of the shaft by 3. So this is the condition when mass of the shaft is also considered in the given problem.